Hi everyone, my name is Kevin Lee, co-founder and CEO of a social venture EQ4Org. I'll be talking about the AI-based sign language technology and how the technology can be used for information accessibility. Starting from the background of this technology, I will tell you about the sign language translation technology and use cases for information accessibility, followed by EQ4 introduction. The first, why sign language? There are 466 million deaf and hard of hearing people in the world, and it is increasing. Sign language is recognized as official language in 71 countries, including Korea, where more than 2/3 of deaf people use sign language as their first language. Many of them have difficulty in reading text, so the sign language is essential in access to information as well as communication. Sign language translation technology. Avatar sign language translation technology has evolved through those three phases. The full motion capture is just capturing the signing and mapping to avatar. It takes 20 to 40 man-days per just one page of text. If you develop the sign language animation dictionary, mapping data between spoken language and sign language, and structured grammar, then you can start RBMT, the rule-based machine translation. Neural machine translation can be started with the NMT engine as well as training data sets. Most of advanced institutes in the world decide to go hybrid between RBMT and NMT due to the lack of training data sets. Of course, the result of the translation engine is not perfect. So revision work by sign language specialists should be followed. Full neural machine translation, like a Google Translator for our spoken languages, can be developed either when you can have tons of training data sets, or there is new translation technology for a smaller data set. Signing avatar is consists of two things, sign language script and avatar player. Sign language script is consists of lemma, gesture of minor hand, major hand, and non-manual signals. So input of translation engine is text and output is sign language script. This is how we make a training data set. Starting from this kind of video, sign language linguists make a labeling for each lemma and non-manual signals. Imagine how long this task takes. Compared to the training data set for spoken language, this data takes over 100 times of resources. Thanks to Minister of Science and ICT, there was a large-scale data project fundings. We could have about 220,000 training data set, which is quite high ranking in the world. This diagram is showing how we can grow. If there is a customer project, the text input to the translation engine. The translation result moved to the revision platform for the sign language specialists. And finally, revised sign language script and player will be delivered to the customer. The flywheel of this kind of platform starts from customer project. The more customer project, the more history data we can get. As the history data can be easily converted to the training data set, the more training data set, it means the better translation engine perform. It reduces the human revision work, which means the cost reduction. The low cost brings more customer projects. The more customer projects means bigger social value creation. Now I will show some use cases of translation technology for information accessibility. As our translation technology evolves, we have done projects like this. The first one is announcement accessibility. When you arrive at the registered public buildings or check into the train, there will be a pop-up screen asking you whether you'd like to get the push message of announcement or not. If yes, your phone will be registered, and whenever there is an announcement, the voice transferred to the speech-to-text, conversion to sign language, followed by push message to the deaf and hard of hearing passengers or visitors with avatar signing and text. This one was implemented in a bullet train network, Seoul subway network, as well as many museums in Korea. Next one is kiosk. Through the pandemic, the kiosk has been implemented everywhere, but not many kiosks has universal design. So we designed it for the deaf and hard of hearing people, the blind, and the physically disabled. Machine vision enabled depth sensor recognize wheelchair to adjust the screen height. Braille keypad and voice UX was implemented for the blind, and avatar sign language for the deaf. Korean government is driving this to the standard and mandatory. Next one is XR docent for the museum. We developed the 3D signing avatar docent program for museums with XR glass of Microsoft, so that the deaf people can enjoy museums with the proper information accessibility. Next one is sign language accessibility for live emergency broadcasting. Like many other countries, Ministry of Science and ICT operates nationwide emergency disaster alerting system. The system aggregates all the disaster information and send it to public broadcaster, and broadcaster will automatically makes the subtitle in text. As the text-only information is not well accessible by the deaf people, we embedded avatar sign language and shoot to home over ATSC 3.0, the latest terrestrial technical spec. We also include the pay TV set-top box and smartphone, so that most of our deaf citizens can have better accessibility to the disaster information. Today, most important information channel is web. But information in the web is mostly in text, which is not fully accessible by the deaf people. We developed the sign language web accessibility at a large knowledge portal developed by Ministry of ICT. It is compliant to HTML5 standard, meeting W3C's web contents accessibility guideline. There are more projects for the deaf and hard of hearing people with avatar sign language technology. Immersive AI-powered sign language education platform at Android TV set-top box to make family with deaf child can have better family communication. Haptic-based music training and enjoyment platform. And sign language accessibility for medical service, especially the emergency room. We are also discussing with the car manufacturer to embed avatar sign language into car infotainment and cockpit system. We also introduced the EV charger with better warning information accessibility at 2023 NAB show. Okay, last one. Let me move on to the EQ4 introduction. EQ4 is a B Corp certified social venture envisioning equitable society with the latest technology. We are pursuing SDG number 4 and 10, solving various kinds of inequality problem with technologies. EQ4 was established in November 2017. It has grown with a 47% year-over-year growth rate. Recently, we are expanding our business area to the people with the developmental problem, developing LLM and GAN-powered easy read solution. Easy read means translation from difficult text to easy text. Those pictures are screenshots of deaf people's SNS with our avatar signing GIFs. Through this, we are innovating how they communicate in SNS. Thanks for your time, and I hope my presentation helped you to think of good social impact business model so that AI can solve various kinds of social problems with equal information accessibility.